Here's a little video on locally linear approximation, where you use calculus to estimate a strange number, not an easy one, to a power or a square root or something. This is 1.97 to the third power. So the first thing to do is to understand, like, what's the function that is modeling here. It's 1.97 to the third power, so we're going to use f of x equals x cubed. It's a cubic function, and here's a quick sketch of a cubic function. It's like this. And we know that, like, at the point 1.97 is super close to 2, and 2 is nice and easy. That's 2 comma 8 on the cubic function. So what's happening here is that we're going to use a linear approximation. That means a line that goes tangent through 2 comma 8 right at that point, and we're going to kind of zoom in and see, all right, what's happening right there, and we're going to approximate now just close to 1.97. So as I'm zoomed in here, just to share with you, like, okay, that line, we're going to get that because we're going to get a point and a slope, and we're going to use calculus to find it. Here is the approximate, what the approximate is going to be. I put a little dot there, and that is approximate. And then the real curve right at 1.97, that is what's actually going to have the actual value. So we can see that our approximation, before we even do it, is going to be a little bit under. It's going to be an under approximation of what actually the value is. So here's what you do. Woo. You say, when it comes to finding the slope, the equation of that line, we always have to start with a point, and we need a slope. The point is nice and easy. That's going to be 2 comma 8. And the slope, we need to use calculus. So the function is y equals x cubed. The first derivative gives the slope of a tangent line at any point, and that's power rule. The first derivative is 3x squared, and now at 2, f prime of 2 is 3 times 2 squared, so that's 12. So right at that point, the slope of the tangent line is 12. So we can use our point slope form. Y minus 8 equals 12 times x minus 2. That is the equation of that line. And so now that power can be used to find any point on that line. Now specifically, we're going to find what 1.97 is right there. So now we use x equals 1.97. Now remember, this is an approximation. It's not going to be the exact value, but calculus has helped us find the equation of that line, and in a local sense, within that space, we're going to find out what the approximate value is. When we put in a 1.97, we get y minus 8 equals 12 times 1.97 minus 2. And now we crank that out and just solve for y. Y is going to be 8 plus, let's see, 1.97 minus 2 is, that's negative 0.03, and that is y equals, that's 1/300ths of that. 1/100th is 0.12, and then 3 of that, 0.36. That's going to be 8 minus 0.36, or 7.64. That's our value, kind of our answer. Now, if we really wanted to find out actually what that was, 1.97 raised to the third power is 7.645 0.5373. A little bit more. So we did have an underestimate, but we came pretty close. And that is locally linear approximations using calculus.